Hello, everyone. Welcome to the webinar on Influx Cloud. My name is Oliver Haynes. I'm the lead developer of Influx CFD software and also the co-founder of Insight Numerics. Many of you know about Influx already and are current users. In fact, many of you have been users for several years. But even if you haven't seen Influx before, I think this webinar is going to be very useful to you. So you can see kind of what the current state of the art is for CFD in the safety industry. And if you want to learn about Influx more generally, about how it operates on a more basic level, there's several resources out there for you, some of our old webinars and videos, and all of our resources on our website, insightnumerics.com. So what we're going to see on this webinar, I hope, is something new that you've never seen before, which is we're going to set up, run, and post-process well over 1,000 CFD simulations from scratch during the course of the webinar. This capability was enabled in a recent update of Influx about a month ago, version 4, and is the current commercial version, so it's available to all of our existing users. And I think it's a very important capability for many users and many people in the industry, even if they don't use Influx. If you're familiar with CFD analysis, I think you'll know how bold this claim is to be able to run 1,000 simulations during the webinar. Other CFD simulation software, you're typically looking at an hour to set up a single simulation, let alone run post-process. One simulation would be an achievement. So we're going to do about 1,000 times more than what's possible with other products. Please type questions into the chat as I go along with this demo. I'm sure you have lots of questions, and we'll have time for answering questions at the end, probably about 15 minutes, I hope. So don't wait until the end to submit them. You can just write them as you go, and we're monitoring the questions during the course of the presentation. Okay, so to demonstrate the cloud capability with Influx, I'm going to set up a risk-based CFD project in Influx, which I have up on my screen here. So you can really see how the cloud kind of integrates into the desktop version of Influx. So this isn't a fully online or web-based system. This is a cloud capability that connects to your desktop version. We're going to do a risk-based CFD project just because it's one that would require thousands of simulations, and you can see interesting post-processing from risk-based analysis like exceedance curves, exceedance contours, and at the end we'll do a quick gas detector optimization just to finish off the demonstration so you can see it from start to finish. So the cloud capability we're talking about, as I mentioned, is really a solver capability primarily. You can do post-processing on it, but primarily it's a solver capability. And so to demonstrate it, I had to first set up some simulations. I have Influx open here. I'm just going to import a relatively simple model into Influx for the purposes of the demonstration. And then I'm going to set up a number of leaks on this model using the risk manager. There's various ways you can add simulations to Influx. The risk manager is one that's just convenient for risk-based analysis. It provides you with a kind of glorified spreadsheet where you can add leaks, and then we can define our win conditions later and see the full matrix of simulations at the end. So I'm going to use a tool just to start defining new leaks. This is a new tool we have for those familiar with Influx, where you can simply click on circular parts of a CAD file, and it will add the inflows spaced around that circle. So I've added 4 different leak locations here. For each one, I've set up a 50mm hole size, and I'm set the fluid to methane. I'm not trying to do too much that's complicated here. I'm just setting up the leaks just so I have simulations for the cloud demonstration. So I'm going to set up about, let's say, 40 different leaks just by clicking on the CAD file and just moving along to different possible leak locations. Obviously, in a real project, you would spend more time with this and take care to make sure that everything was input correctly. I'm just adding some leaks to the project just to get some going. Let's add some here just to show you. Also, don't need to do axis align leaks. You can do ones that have kind of got an angle to them. And let's just do a few more. Let's do, let's say, 3 down here. Let's see, another one here. And then 2 more along here. And finally, let's put one, say over here. So I think that'll be enough leaks now for the purposes of setting up a large number of simulations. As this is a risk-based analysis, I'm also going to assign them a leak frequency. Again, this is something you need to take care with on your actual project. But here I'm just going to select many of them and select a kind of bulk frequency so that I have an overall risk in the project. Let's just select 5. Okay, so I have 40 different leaks now with different leak frequencies all set up in the project. Next, what I'm going to do is to set up some wind conditions. I'm going to use a wind rose and select 8 different directions. Kind of neat little tool we have now is to randomize the wind rose, so you can see. I've just clicked the randomizer for the probabilities, so it gives you the kind of example wind rose that you can then use for the analysis. And now I've got the full set of simulations set up. So I've got over 1,200 dispersion simulations set up. I could set these up for fire simulations as well, or any other type of analysis that you would do in Influx. But I'm going to stick to dispersion simulations for now, but any type of analysis is available on the cloud. And I'm just going to add all those simulations to the project. It's going to add 32 wind simulations and 1,280 dispersion simulations. So now I've got the project with all these different leak locations. I can see the dispersion simulations and wind simulations. Now, if I were to run this just by pressing run locally on my desktop, it would just run the first simulation, then the next one, then the next, and it would just go through in a long list. And what we're going to see with the cloud is that all of these simulations run at the same time. Before I run them in the cloud, I'm actually going to set up one more thing to help post-process the data. A risk data set. This is for risk-based analysis in Influx. It's kind of domain where it will record one variable for all of the simulations, so you can kind of do exceedance contours on that variable, for example. Okay, so my project is done. I've set it up, and now I'm going to start running this on the cloud. To do this, I can press run, and then instead of choosing locally, I just choose in cloud. It shows me all of the simulations in the project. I'm going to select all of them and press run in cloud. That's as simple as it is. To run a simulation locally versus in the cloud in Influx is really the difference of a click. It's either selecting to run something locally or to run it in the cloud. So what we have right here is the Cloud Manager. This is going to show us some information about the what's going on in the cloud. The cloud system is based on Microsoft Azure. So what's happening now in the background is that the project was uploaded to our cloud servers, and it's deployed, or it's starting to deploy, many virtual machines. You can see the specs of these virtual machines up here. Each one has 8 cores per virtual machine and 32 gigs of RAM. What it's doing is it's first of all going to run the ventilation simulation, because it needs these complete before it's going to start the dispersion simulations. So because there are 32 wind simulations, it's actually going to start 16 virtual machines. It's actually running 2 simulations in parallel per virtual machine. Now, whether it will either run 1 simulation on a virtual machine or 2 in parallel on a virtual machine, depending on some analysis it's doing of how big the simulation is. So if it's a very large simulation and it needs a whole virtual machine by itself, it will just deploy a virtual machine for that particular simulation. But it's decided that these simulations are lightweight enough to actually run 2 side by side on the same virtual machine. This graph, what it's showing is the dotted line shows the number of virtual machines it's firing up, and the solid blue line shows the number of virtual machines that are actually running at this moment in time. The pink line shows the current progress of the virtual machines, of the project. You can see here that the ventilation simulations have all started. So as they're being solved on the cloud, the data about their progress is being sent back to Influx, and it's reacting just as if you set up and run a CFD simulation locally. So there's just no difference between the two. You're getting the same data back. It's just that one is running in the cloud and the other is running locally. There's no CPU usage dedicated to running simulations on my local machine. My local machine is doing nothing at the moment. Now, this isn't the only way to run simulations in Influx. As a comparison, there are 3 different ways that you can run simulations in the current version of Influx. The first is where everyone starts, which is the local simulation. So this is one that runs on your local machine, the most basic operation. You press run, and the simulation will start locally and finish locally. Your data will be stored on your local machine. The trouble is, if you have a very big project to run, you might have 1,000 simulations, which is not huge, but it's significant. And if each simulation takes 30 minutes, then it's taken 21 days for that whole project to complete. Because for the one machine you have, your local machine, it's running the whole 1,000 simulations. Many of our users prior to Influx version 4 with the cloud capability utilized a distributed method where you can split the project up into separate, smaller parts and then run those small parts on dedicated machines. These require machines that are physically available to you. So they might be in your company, you have analysis machines, maybe you can get the use of a few of those. Some of our customers created their own virtual machines, but it gets unwieldy to handle too many of those. Typically about 10 machines would be quite a lot for somebody to have access to, and you can see that if you had 10 machines though, the runtime would dramatically reduce by a factor of 10. So to run the same project on the 10 machines just takes 2 days. The cloud is much faster because the 1,000 simulations are run basically on 1,000 virtual machines. For all intents and purposes, 1 simulation per machine is how fast the cloud runs. So if your longest simulation takes 30 minutes, the whole project will take 30 minutes because the whole thing's being done in parallel. So this is a kind of a game changer in the sense of how fast you can run very large CFD projects. But also a game changer in the sense of who can perform these types of projects. It's now no longer just CFD experts with a large computing capability. Anybody on their laptop can set up and run giant CFD projects using Influx Cloud. The combination of Influx, which is very automated, with the highly automated and parallel nature of the cloud makes this a very powerful tool. So we have our first simulations complete. Looking back at the Cloud Manager, we can see that many of the ventilation simulations are complete. And the dispersion simulations have now started. On the progress, we can see that many more virtual machines have started, and in fact, we're probably, yes, around just over 600 virtual machines will be running in a few moments. The progress of the overall project is increasing because all of the dispersion simulations are running, and you can see how many are running in the top here. So we have currently nearly 1,000 CFD simulations running in parallel. Now I can post-process the data from these simulations, just as I post-process any data in Influx. So, for example, let me just turn these leaks off. I can, for example, add vectors and post-process data to see, for example, the wind vector for this particular leak, this particular wind condition. It has downloaded the data locally in a temporary file and then opened that data for that simulation, so we can actually look at it locally on my machine, and I can see the data. I can move it, up and down. This is exactly how the local version of Influx works. So it's totally transparent to the user about whether a simulation was run locally or run in the cloud. Also, all of the monitor data, so any monitor data about monitor lines, monitor regions, things like that, is all streamed back automatically to the cloud, to the local machine from the cloud. And I'll show you more of that when we've finished some of these dispersion simulations, so you can see some of that monitor data coming through. So now we've got nearly, well over 1,000 simulations running in the cloud. I think it's a good time just to kind of take a step back a little bit. Now you've got a feel for what's going on and can see all of these simulations running at once. Just to talk a little more broadly about why we've developed the cloud capability, how it's different to existing cloud capabilities on other CFD software, and what I think it will mean for the industry and the type of analysis we can do now that we couldn't do before. So one important aspect of what I think the cloud's going to do is to increase utilization of CFD in the safety industry. The major reason why CFD is not used on projects is because it's too complicated, it's too slow, and you don't have people that can run CFD. It's seen as a heavyweight option. And even if it's the best option, it's often not chosen because it's so heavyweight. Now, you can see how lightweight Influx is. It doesn't require any CFD expertise to run, and it doesn't require now any hardware either, only the laptop that you're managing the cloud project from. The utilization of CFD, I think, is a problem in our industry in that it's underutilized, and often more basic models are utilized where they perhaps shouldn't be. For example, where you've got a complicated project with a complicated geometry, you can't use tools like FAST, where you have interactions of plumes with buildings, or even plumes that are directed into the wind. You can't use simple models like FAST on that. Instead, you have to use CFD modeling, but often there is pressure on the project and pressure on the schedule to get the project finished, and that will inevitably mean you use quicker tools. This was referenced, I think, in the recent British standard on fire and gas mapping, which is, our kind of main area that we're interested in, where the quote is from that schedule pressure might require reducing the amount of CFD modeling, kind of highlighted exactly what we're talking about in the sense of when to use CFD modeling for gas detection versus more basic geographic methods. But that is now addressed by Flux Cloud. Another time where CFD is not used when it should be is when there are late changes to a project. Maybe you've finished the project and at the last moments, some equipment has been moved from one place to another, some pressures have changed, some compositions have changed, things like that. These happen all the time. And often it's too late in the game to rerun the CFD. So you either take results that are old and say, well, they're probably okay, or you run a very limited set to try and do something, but you don't rerun the whole project. And now you really can rerun the whole project. If you had a new CAD file here, I could just unload the old one, load in the new one, and just rerun it and have the whole project done in the matter of minutes. So this is where I think it's going to really help in the kind of popularity of CFD, because it's going to be used more often. Secondly, I think the Influx Cloud is going to support risk-based analysis, which I still think as the CFD modeling hasn't fully reached its potential on this type of analysis. It's been around for a while. People were doing risk-based analysis on explosion modeling many years ago. But it still takes a long time, in the realm of weeks, and it's still very expensive. And this is just no longer the case. I'm doing a risk-based analysis during the course of this webinar, and there's no time pressure. It's gonna finish well within the time that this webinar is happening. So the reduction in cost and time for risk-based analysis for CFD, I think, is going to allow it to become, or to reach its potential as a type of analysis that will be useful in the safety industry. Secondly, I think that the number of simulations that have been done using risk-based analysis is typically too few, because it just wasn't possible to run several thousand simulations. And now with the cloud, we're looking at supporting projects that are on the order of 10,000 simulations. And really what we're trying to do at Insight Numerics is support projects that are unlimited with the number of simulations that you can use in a single project. So there is right now a kind of broad limit of that order of 10,000 or so. But I don't think that limit's going to stay around for much longer. Finally, it opens up the door to full CFD QRAs to be done. Presently, people kind of, if they use CFD for QRAs, try to integrate them with existing QRA models that also use simple tools. But there's no really well-built full CFD QRA tool. And this is why I think Influx is going to be the first one, because it's going to build off the cloud capability to support the large number of simulations required for a CFD QRA. Finally, I think the other benefits are going to be that it opens a door to important research topics that perhaps haven't been explored well enough to date. When we're setting up risk-based projects, we think, well, maybe 4 wind speeds, or 3 wind speeds, or 8 wind directions, or 4 wind directions, but there's no real guidance on how many to do. It's only really what has been done in the past. But there's been no kind of rigorous analysis on how many do you need. I think we need to do that analysis. We need to try and come up with a way of talking about project convergence, not just convergence of one CFD simulation, but the convergence of the project overall. And that type of work is going to really benefit from being able to run thousands of simulations at a whim and do some experiments and testing on those types of things. And I think the last bullet point there is going to nail down the importance of a kind of single simulation accuracy versus project accuracy. This is a very interesting topic in my mind, because we could run one CFD simulation perfectly and I could take a year over doing that. Or I could run 100,000 simulations that are very coarse. From the project point of view, which is better? A single simulation doesn't tell us anywhere near enough. 100,000 simulations that are inaccurate might tell us a lot, but not accurately enough. But where is that optimal point? And I don't think we've kind of really understood where that is yet. Finally, a few words about using Influx Cloud on projects. As you can see, I've run now many simulations. I have about 350 dispersion simulations complete, and we're half an hour into the webinar. So it gives you a sense of how the cloud will reduce project pressure. Just like any analysis, Influx follows the garbage in, garbage out principle. But if you can spend more time setting up simulations because you're not under pressure because of how long they're going to take to run, then you're going to make fewer mistakes. Mistakes, I think, are most often made under time pressure because of deadlines. And alleviating that time pressure by allowing thousands of simulations to run in an hour really helps with making sure we're doing a good job as engineers in this industry to set up simulations properly. Another nice thing about using particularly Influx Cloud is that the quality of the simulations is all exactly the same. We're not making individual meshes. As you've seen here, I've set up thousands of simulations, but I haven't talked about meshing at all. And that's because in Influx, all of the numerical side of the simulations is done automatically. The domain sizing, the meshing, the boundary conditions, the numerical setup, all of that is done automatically by the software, and it's a consistent level of quality for every single simulation. This isn't true where you have to use other products where you have to manually start defining mesh sizes and all that kind of thing for every single simulation. Very hard to check if everything's been done correctly on those types of projects. And on that note, the kind of integration of Influx Cloud with the desktop version of Influx, I think allows these very large projects that use CFD to be clearly understood. Areas are kind of easy to find. I can see exactly what flow rates I used, what hole diameters I used, and what wind conditions I used to set up the project. Other kind of cloud-based software often uses scripts that it's not exactly clear what the boundary conditions are and if they've been set up correctly in each one. It's very easy for mistakes to just be missed, because nobody can reasonably check thousands of files from other CFD software. But it being all nicely integrated into Influx really promotes the transparency in the project. We've got many dispersion simulations finished, and I'll go back to Influx in a moment. You can just see on the left the number of virtual machines is winding down as simulations complete. At the moment, I have 742 simulations currently running. That number is going to reduce as more and more are complete. And at the moment, I have about 700, just over 700 simulations complete. While the rest are completing, I'll talk a little bit about licensing. We've also gone a bit of a different direction from other products on how we do licensing for Influx Cloud. And it's done on a per simulation basis. There is a fixed cost per simulation. So if you have 1,000 simulations, you buy a 1,000 simulation license from us. That gives you the ability to run 1,000 simulations regardless of what they are. They could be fire, they could be transients, they could just be ventilation, you could do indoor, outdoor, anything you want, but it's a fixed cost. Almost all other CFD products out there, not even just in our industry, but kind of other commercial codes, use a kind of CPU hour type approach where you're buying time. And I don't like that because it's hard to estimate how much it's going to cost. You just don't know, because you don't know how long simulations are going to take. Also, if a simulation takes a long time, that's partly on the developer to improve that. I much prefer the per simulation basis licensing, because you know beforehand how much the cloud's going to cost to use. You can also ring fence that cost and apply it directly to a project. So even if you have an annual license for Influx, you can say, well, I'm going to run these 5,000 simulations for this project, and it's going to cost this amount that I can then charge to that particular project. The per simulation licensing also aligns our goals. When we run simulations on the cloud, it's not free for Insight Numerics either. We're paying Microsoft ultimately to use their machines, and we are charged on a time basis. So us making our simulations run more efficiently lowers our costs and makes the software run faster for you as well. So that's, I like that kind of alignment between you as users and us as developers. As I touched on, the Influx Cloud license does require a supporting Influx license. So you can't just buy a cloud license if you haven't got an existing Influx license. You need Influx to set up the project. The cloud just gives you the ability to run, the cloud license gives you the ability to run simulations on the cloud. If you don't have a cloud license, but you just have an Influx license, you can still run simulations locally. You can run distributed simulations on multiple machines. That's still possible, but it's just with the cloud license, it gives you that capability to run the simulations using the cloud. So I'm going to swing back now to the project, and we've now got approaching 1,000 dispersion simulations run. Just like the ventilation simulations, I can start post-processing the dispersion simulations. I'm going to add a 100% LFL gas cloud for the first simulation I defined. You can see the jet coming out of the hole, spreading and slightly turning into the wind. As I reduce the concentration I'm plotting to 10% LFL, you'll see the gas cloud move more, be turned into the wind, and at 1% LFL you can see the very low gas concentrations and where they go in the project. Now these gas clouds have been generated for all of the dispersion simulations that are complete. And using the risk data set, I can start to post-process the kind of risk-based results from all of those combined gas clouds. What I'm doing here is just downloading all of that data about all of those gas clouds from the cloud to the desktop. It's not all complete, but I can still start to get a feel for a lot of the risk-based analysis. Just let it save the project, and then we'll start looking at some of the kind of risk-based data you can get. I'm going to just minimize this for now so you can see the whole project. But so we now generated thousands, or well, over 1,000 gas clouds for all of these leaks and all of the different wind conditions from the risk manager and the cloud solver. So I can now add a risk contour of exceedance. For example, here, this shows an exceedance of 10% LFL at a certain height of 3 meters in the project. This isn't new. This type of plot has been available in Influx for several years. I'm just showing it to you here as a kind of example of how you can get to do risk-based analysis during the course of, it's been 40 minutes now since we started. And you can see, for example, that in this contour plot is showing how many simulations exceed 10% LFL. For example, here I've got over 200 simulations exceeding 10% LFL. So that's what I would call a scenario-based exceedance contour. You can change this to frequency-based. So it sums up the frequencies of all those scenarios, and we can see how frequent exceedance of 10% LFL is. We can now move that up and down and see how it changes with height. Also, we can look at different exceedance like 20% LFL and how that changes. So this is a statistical risk-based analysis. We can also look at, for example, gas cloud sizes. Here I've got all of the dispersion simulations and all of their different cloud volumes. I've got them either as meters cubed or as an equivalent diameter of a sphere, so you can see how big the spherical gas cloud kind of is. I can see exceedance of those gas clouds. One moment. This is actually quite instructive. The exceedance plot failed, but I can now actually open up the cloud project, and it's not disappeared. It's all here. It's still all running on the cloud. So I'm back to where I started before showing that exceedance exceedance plot. Then go back here and select the exceedance contour. So what I'm going to do now, after looking at some of the risk-based analysis, is actually to start running a gas detector optimization study as well. So what I'm going to do is to look at how I would set up gas detectors to detect all of these different gas clouds I've added in the project. So for example, I'm going to add some monitor points. This is going to be where I can put gas detectors. It's kind of options for the gas detector optimization tool of where it can put gas detectors. And I'm just going to give it options. I'm just going to do some clicks here to give it options of where it can add gas detectors in the algorithm. When I've done this, what I'm going to do is to basically use the gas detector optimization tool in Influx. And this tool will select which of these points I've given it are optimal for positioning gas detectors. Normally, I take kind of much more care over this and do this properly. Here, I'm just doing it quickly, just so we can kind of get a feel for how it works. But these aren't totally ridiculous positions for gas detectors. And we might put some more over here. And finally, we're going to add some, let's say, put just one more line maybe over here. And finally, we're going to put in some monitor lines to show open path gas detectors. So we can include those in the risk-based gas mapping analysis too. 1314, you can choose whichever ones of these it likes. So now it's nearly completed all of the simulations. I'm just going to download the risk data set one more time, just so that it has all of the information it needs to do the gas mapping analysis. You can do the gas mapping analysis even though it's not finished all of the simulations. It just won't have detection for those simulations that aren't yet finished. But we can do a kind of intermediate gas mapping analysis to see where we are on the current simulations that we have. So I can just right-click once it's just cancelling this. One moment. Alan, yes, here we go. And I can now right-click on the risk data set and go to gas detector optimization and start running the gas detector optimization tool. At the moment, it's chosen from all of the different positions on the monitor points and monitor lines I've given it. It's only achieved 76% coverage. If I change the alarm settings and use a risk-based analysis and maybe lower the target coverage, I can get a nice-looking detector layout. Here, for example, it's chosen all of these different detector positions for the gas detector layout, including 2 monitor lines. I can see the 2D view of that to see how it would look like. And so this is kind of how far you can take analysis and processing of CFD simulations using the cloud capability. So in conclusion, we've gone a long way during this course of this webinar. We've seen how you can run thousands of simulations using Flux Cloud. I hope I've kind of conveyed to you the kind of new capabilities that this cloud allows you to think about. First of all, in terms of lowering the bar for how much IT infrastructure you need to run CFD. Right now, a laptop is enough to run the full risk-based CFD analysis. If you don't have very good analysis machines, this is a game changer for you. If you do have analysis machines, often those are under pressure from other types of analysis. And so it allows you to free up existing analysis machines. So you can use other types of software on those analysis machines. This whole project didn't require any CFD or IT expertise to set up. The level of automation is very high. If you understand your site, you understand the process conditions, and you have knowledge of which leaks to look at. In other words, if you can do something in fast, that kind of capability, then you can easily use Flux and do risk-based CFD analysis. I think this capability really enhances your in-house capabilities. If you sometimes outsource CFD projects that are too big for you to do, or you outsource all CFD projects, you can really think about doing those in-house. And as consultancies, consulting companies can deliver projects even when very tight deadlines are imposed upon them. Finally, I think Flux Cloud gives you a huge competitive advantage over other companies that use other CFD software. You can simply offer things that they can't reasonably perform. You could bid on projects and have results turned around in a couple of days. I mean, that's the kind of thing you can offer with Flux Cloud that you just can't do with other CFD software. So I think that draws the webinar to a close from my point of view. There are still 12 simulations running, but we've completed 1,276 of the dispersion and all 32 ventilation. So we've done over 1,300 CFD simulations during the course of the webinar. So now we have 10 minutes. I was a bit late on the demo, but we have about 10 minutes to go through questions. If you have questions afterwards, you can email info@insightnumerics.com, ohaynes@insightnumerics.com. If you want to learn more about Flux, you can go to the website, our website, insightnumerics.com. Okay, Alan, do we have any questions?
Hey, Ollie. Yep. Yes. With the downloading of the risk data, it showed that the cloud data is stored there, but how is the rest of the data stored? And is it local with like solver files, because I'm familiar with that, or is it stored elsewhere?
It's stored elsewhere. So all of the simulation data is stored on the cloud. So it's nice because the actual file size, if you don't have a risk data set, the file size might be a few megabytes for your whole project. So it's nice that you can kind of email projects to each other. It's that kind of size. It's kind of a different way of thinking about it because you're not used to being able to email each other CFD projects that have thousands of simulations in them. But you can definitely do that with the cloud capability. The risk data set is definitely, to look at that risk data set, you need to download that locally onto your machine. That happens, very quickly, as I've just demonstrated. So that is stored locally. If you want to retrieve all of that information from the cloud, you can download the completed simulations from the cloud. So you don't have to store it forever on the cloud. You might want to archive it yourself, or you just don't want it forever living on Insight Numerics Cloud. You can download all of that and clear that data from the Insight Numerics cloud service. Do you have another question, Alan?
Yes, you mentioned running 10,000 simulations with this capability, but for some other CFD codes or cloud offerings can sometimes grind to a halt depending on the utilization. Can you describe further if you've actually run this with 10,000 cases?
Yeah, absolutely, yeah. Yes, and actually we're looking to do more than 10,000. I mean, I feel that 10,000 is a kind of upper limit of where we are at this moment in time. Yes, we've run 10,000 simulation projects in Influx. The number of virtual machines available to us is enormous. We're using Microsoft capabilities. This type of project is not a huge ask for Microsoft to provide 10,000 virtual machines. It's not a huge number. If there are simulations, times where the server gets so overwhelmed that we're being throttled back for some reason, there is a queue that we put in place for cloud simulations. So it might take a bit of time for the virtual machine to be allocated. But I think we're a long way from reaching that limit. If you use Influx Cloud, I'd be extremely surprised if you weren't instantly able to do what I've just done and get a virtual machine to run your data. In fact, just on that note of 10,000, I think that's a limit right now, and I'm not happy with that limit personally. I would much prefer to be able to handle 100,000 simulations in Influx, or potentially unlimited number of simulations. Why would you want unlimited? You could run ongoing projects to support operations, just on a cloud server, and just have them keep going and have a kind of live update of QRA type information based on current conditions, recorded wind speeds, changes in process conditions, all of that kind of stuff. So kind of another interesting possibility of what you can do with the cloud. Next one, Alan.
Would you use the cloud for updating risk data? I've used the risk data sets in the past, and they can be sometimes slow to update if I had a change to the project. So can I use the cloud for that also?
Yeah, that's a great question. This has been, I think, a problem with Influx to date, is that when you run a big project using distributed machines, you can get your data quickly. But if you want to do some more post-processing, it does that all in serial. You can do it distributed, it's just a bit of a pain to do that. So if you have a project with 1,000 simulations in and add a new risk data set or update it for some reason, it will load in one simulation, then the next, then the next, and the next. And that can take several hours sometimes. Now, all post-processing can also be done on the cloud, which is a really nice capability. It's not just a solver capability. If you add a new risk data set to your existing projects, or an existing cloud project here, for example, and I was to update that, it would send that risk data set to the cloud. It would start up thousands of virtual machines, get the risk data for each one in parallel, and then send it back to the desktop. And so you can update a new risk data set in a few minutes. And in fact, any batch process like batch image output, all kinds of if you add new monitor points afterwards, things like that. All post-processing can also be done in the cloud. Importantly, you can also do the post-processing in the cloud, even if you have a local project. So we're not requiring a cloud license for you to use Influx post-processing. That's for free in the cloud. So if you run your simulations locally, you have an existing project that runs simulations locally, you can upload the simulations to the cloud and then take advantage of all the cloud benefits like post-processing, things like that. And that doesn't require a license, a cloud license. You need your Influx license to do that. So that's a really nice feature we were happy to offer, because basically it's so cheap for us to do that kind of post-processing. It takes so little that we're happy to take that loss to enable users to do their post-processing a lot quicker. Any further questions, Alan?
Yes. Now, you mentioned the credits are used with the license, but if I'm running simulations with the credits, can I use my Influx license still on other things, or is it locked when it's running the cloud?
No, not locked at all. You can. I could have just closed this project and opened it again. In fact, I might just show that. I'll save this project. So you can, yes, you can start simulations off in the cloud. You don't have to keep Influx open. You can then just close Influx and walk away from it, and all of the simulations will still be running in the cloud. So when they complete, you can just come back and open up the project again, and just like it's saying here, the simulations will show them are complete. So you can go away and do other stuff. It's really nice. You can set them all on the cloud and then close the project down and start working on a different project. Any more questions, Alan?
Just more general is, since this information is stored in the cloud, what are the terms for how long it is stored there?
Storing information in the cloud is incredibly inexpensive. So we're storing it, I think I have to look at the language in our license agreements, but basically for I don't think it says forever, but there's some limit on it, but it's many years. So yeah, cloud storage is very, very cheap, and it doesn't require you to have a kind of Influx license. Like if you let your Influx license expire, we won't delete the data. You can then buy another Influx license later on and reconnect to that project, and it will all be there on the cloud for you to look at or download. Maybe just one or two more questions, Alan, if there are any.
No, I think we've covered everything, Ollie. Thank you.
Okay. Yeah, well, we're at our stage now. I hope this has been an instructive webinar just to see the kind of thing you can do with Influx Cloud and Influx in general. I'm really enthusiastic about it. I hope it does make an impact on your projects and you can do your projects faster and better quality and have fun doing them. If you want to have a play around with the cloud yourself, you can just download Influx from insightnumerics.com. There's a register button on the top right. You can register a new account or log into your existing account, download the current version of Influx, and then you do get a demo license when you download Influx. It doesn't include cloud credits, but if you just email us, we'll be happy to add some cloud credits to your demo so you can have a play around with it yourself without no cost. Thanks everyone for joining. keep looking out for further webinars. I think we're going to do a few more on Influx in later this year that will be of interest. We might do a more basic overview of Influx. As I alluded to, we're working on QRA tools in Influx too, so if we get something with that, we'll do a webinar later on. But in the meantime, thanks everyone for joining, and hope to see you around soon. Thanks a lot. Bye-bye.